Hi everyone, so hopefully you can see my screen that I'm sharing right now. Aruna, could you give me a quick thumbs up if you can see it all okay and hear me okay? Perfect. Right, so I'm going to get started right away because I know we've only got a short time period for this, but just to introduce myself, my name's Beth. I work for a company called Sonnedix and we are a solar power producer. So we thought we'd get involved in the Youth Climate Summit to give you a view on renewable energy, solar energy, why it's important and why it's vital in the fight against climate change. So I'm going to talk to you a little bit today about electricity in general, about why the current electricity production is a bit of a problem in the fight against climate change and how we can transition into a brighter future through the use of solar energy. So of course, put any questions that you may have into the comments box, and if we've got some time at the end, I'll happily go through and answer some of those for you. But I'll just get started for a little bit now. So I'm going to get you thinking first of all about a world without electricity. I think it's fair to say that we rely quite heavily on electricity at the moment. I mean, this summit wouldn't be going forward in the way that it is without electricity. We need it for the Wi-Fi that we're all using to log into these Zoom webinars, and I need it to present and share my screen with you now, or my laptop battery would run out pretty quickly. So electricity is a really important part of life as we know it, but believe it or not, people did manage before electricity. I think candlelight was probably the most popular of those pre-electricity times. You needed candlelight to read, to eat, to walk around the house, to stop you from tripping over and from hurting yourself, just simply to go to the toilet or go upstairs to bed. There were no fridges to keep your food from spoiling, so pantries were used, meat safes were used to keep everything cool, and obviously food just didn't generally last as long. We're lucky now we can put something in the freezer, it will last for a very long time and it stops us from wasting anything and wasting our money. You had to cook through fires, so open fires or fire-powered ovens were used to cook your food, and you didn't have the nice luxury of ovens and other kitchen appliances to cook and prepare any food. And of course, washing was done very manually. This is probably one of the biggest time savers, was the invention of the washing machine, which obviously is powered by electricity. So I think the summary here is that life was just generally a little bit more inconvenient. And thanks to electricity, we can do a lot more things a lot more quickly and a lot easier with less of that manual labor required. So it's a big part of our lives. And I think sometimes we overlook this, we don't take it for granted, but it's very, very important to everyday life now. So we're going to look quickly at what electricity actually is. So this guy here is Benjamin Franklin. He was really the one that kind of started this modern electricity revolution. He started to provide more understanding about what electricity was and how we could use it in our lives. And he really laid the foundation for other scientists moving forward. So people like Thomas Edison, who came and invented the light bulb and a lot of other appliances and started that invention wave. But really the theory came quite heavily from Benjamin Franklin. We'll skip to 1878. The first electric streetlights in the entire world were actually put up in London, so nice and close to where I'm living, and I can imagine a lot of you are living. The first streetlight there is a little cartoon to kind of demonstrate that with all the people watching in awe. And actually a town in Surrey was the first town to actually have public electricity that was available to everybody. So the UK was quite significant in terms of those electricity breakthroughs. And then, of course, we started to get a lot more developed. We had things like the light bulb and these appliances, and electricity became a lot more mainstream. But of course, it wasn't until really later on that we started to use this as heavily as we do now. I think it's fair to say if we have a power cut, we all go into a slight state of panic. And really that was towards the end of the 1900s that really electricity became as we know it today. Fun fact, so one lightning bolt can actually light up about 100 light bulbs for an entire day. So that's the power of lightning in comparison, which is of course still electricity, just not in the sense of putting a plug in the wall. And to get electricity, we need to make it. Okay, we need to generate electricity. It's commonly done in these things here called power plants. This is a coal power plant here. But we have to make it. It's called electricity generation. And this is where some of the problems come in. There's a problem with how we've been producing electricity really up until a few years ago. And really why I'm here to talk to you today about how we start to change how we produce electricity. So greenhouse gases and electricity, this is where we start to get into the topic of climate change a little bit more. So since the Industrial Revolution, we've been extracting huge amounts of things called fossil fuels. So this is gas, oil, and coal. We extract these from the ground, we burn them, and we create energy. So that's the simple kind of explanation behind this. So you'll see the coal power plant again at the bottom. We're burning coal, we get some energy from it, and that provides a huge amount of electricity that, as you know, we use every single day and we heavily rely on. And as we went through the Industrial Revolution and we started to do more and have more processes and manufacture more, obviously we produced huge amounts of electricity. And this has had a lasting effect on the planet as we know it. Because as we do this, we create loads of greenhouse gases. Okay, so carbon dioxide, methane, nitrous oxide, these are some of the main examples. And these are all produced as a result of burning these fossil fuels. And these go out into the atmosphere and basically lead to something called global warming, which is essentially a warming of the whole planet, which then contributes to climate change. And this is through the greenhouse effect. This is where essentially, if you imagine the Earth as a bubble, you've got the atmosphere going around it, all of these particles go out into the atmosphere, and as heat comes in, it gets trapped, and gradually the Earth's temperature increases. There's another greenhouse gas, which is water vapor. This is actually the most common, the most abundant of all greenhouse gases, but this is the one that isn't really produced as a result of these activities. Okay, so as we're creating more and more electricity to meet our needs, we're also creating more and more greenhouse gases, which are being released out into the atmosphere. So why is this a problem? Well, as I said, this leads to something called climate change. And climate change isn't necessarily a new thing. Throughout history, our climate has changed constantly. There have been multiple phases where the glaciers have retreated, advanced, and everything has kind of been in this up and down motion. This was until about 11,700 years ago, which was the end of the last ice age. And this is really when the modern climate era began. And this marked the kind of birth of human civilization, everything like that as we know it today. So why is it now an issue? It's an issue now because it is largely a result of human activity. This is the main difference, and this is called anthropogenic climate change. This is where the climate is changing as a result of what we are doing. And it's also occurring at a much faster rate that hasn't been seen before. So this is the main problem that we've got. And it's not just a case of everything warming up. Obviously, we feel it. We feel the heat waves. We feel the nice hot summer months, which I think sometimes we're grateful for. But when we look at the deeper impact of this, you've got warming oceans. So the oceans actually take in about 90% of this extra heat. So they're getting warmer, which obviously impacts the animals that are living in there. You've got the ice caps melting, as you can see by the second picture there. It's 286 billion tons of ice are lost every year in Greenland, which is a huge amount when you think about it. As a result of this, obviously, we've got sea levels rising, which causes flooding, like you'll see in the middle picture there. And we even get this in the UK, so this is impacting a lot of different nations around the world. You've then got the oceans acidifying. So ocean acidification causes things like the coral to bleach here that you'll see in the fourth picture along. And then, of course, we get more extreme weather events. So whether it's hurricanes that are happening over in the Caribbean or wildfires that are happening in California or in Australia, these are all a result of climate change. So how can we solve the problem? So this is what we do at Sonnedix, okay? We are thinking about how we can solve the problem by taking out some of the biggest impact which comes from producing electricity. So we're going to go back a little bit and look at how we produce electricity. There's two main sources. You may or may not have heard of these terms before. They are renewable energy and non-renewable energy. Okay, so thinking about non-renewable first. This is energy that comes from resources that are not replaced or that are replaced only very slowly. And this is your coal, your oil, your natural gas, all of those fossil fuels that we were talking about earlier. These have taken billions of years to be produced. They've been extracted from under the ground, and these essentially run out. So we're on track to run out of coal and oil and gas pretty soon. On the other side, you've got renewable energy. So this is energy from sources that naturally replenish, things like the sun, wind, water, all of these that we have a constant stream of and that we're not really going to run out of. Yes, it may fluctuate. We have darker days with less sunlight. We have days where there's less wind, but this source is constantly provided. And this solar energy that we've got there is what we do at Sonnedix. And renewable energy plays a really important role. It reduces the emission of greenhouse gases. It's getting much cheaper as well. This was always one of the barriers to renewable energy, is that it was a lot more expensive, but it's becoming much, much more affordable. There's overall less of an environmental impact, and it's constantly available. We're not going to run out, and we're not going to be in a situation where we have no means of producing electricity. So what is solar energy? Now, it's very, very complex. Even I work for a solar energy company in our sustainability team, and I don't know the ins and outs of solar energy for sure. It's very, very complex physics. But it was Einstein that really came up with this thing called the photovoltaic effect, which is essentially converting light into electricity. And that's what we do with these solar power plants. And this actually earned him the Nobel Peace Prize in 1921 for his contribution to this. So in a very, very, very simple terms, this is what happens. Sunlight shines onto the solar panels. The solar panels, which contain these solar cells, convert the sun's energy into electricity. And then this produces the electricity that we use to power our homes. So this is a very, very simplified version of the process. These solar panels here are usually made of something called silicon. It's basically purified sand, nothing more complex than that. And it's actually the second most abundant element in the Earth's crust after oxygen. So it's very, very common. And basically, when it's mixed with other elements like phosphorus and boron and some other examples, it reacts with the photons that are in the light, and it produces electricity. It stimulates those electrons and produces the electricity that we can then use to power our homes. So it's a complex process, and obviously Einstein won the Nobel Prize for coming up with this theory and really enhancing that breakthrough and allowing it to happen. But what does this mean in real terms? So we measure solar energy in something called megawatt hours, and we can say essentially 1 megawatt worth of a solar PV plant is about the same size as a football pitch. So that's 1 megawatt, and this powers approximately 200 homes for a whole year. Obviously, this varies on the different countries and dependent on how much air conditioning or heating or cooking that country does. So this is according to US data, but that's basically 1 megawatt powers approximately 200 homes, and that's about the size of a football pitch. So that gives you a kind of idea of what this means in real terms. And this avoids about 1,000 tons of carbon dioxide emissions every year that would have been created as a result of using coal instead. So as you can see, it's much less of an environmental impact and basically reduces that impact on climate change and makes sure that we can go ahead in a much more sustainable way. Another fun fact, takes sunlight about 8 minutes and 20 seconds to travel from the sun to the Earth's surface, despite its incredibly long distance away from us. But it's a really useful form of energy and means that we've got this potential to create more and more electricity, but in a healthier way. And solar's at a tipping point. So there's a lot more work to be done. You'll see this graph here. We're at this tiny little area on the left at the bottom. That's our current production of solar energy. And we need to get all the way up to the top there. That's how much our population is growing, how much electricity we're going to need in the future. And when we run out of some of these non-renewable resources, there's going to be a heavy reliance on renewable energy like solar. So we're only really at the start of the journey. There's still a lot more to do. And look at where we need to be by 2050. And what does the future of solar look like? So at the moment, you'll know solar as those massive fields of solar plants, lots of solar panels all sitting there collecting in the sun's energy. But what does it look like in the future? Now have a think to yourself, any ideas of how we could use solar in the future? And I'll give you a few ideas on the screen as well. So these are some of the ones that we came up with. You've got solar powered blinds that obviously are transparent, see-through, doesn't stop you from seeing out of the building, but still collects in that light and converts it into electricity. Can you put solar panels on top of cars, on top of planes, on top of trains, on top of boats? Can you use solar power as roof tiles? That way you haven't got the big panel stuck on your house, but you're still producing your electricity. Can we float solar? This is started to be putting it on lakes, on the oceans, much like they've done with wind energy and moved it out to the side. We could put it there on the water as well. And can we use it in other purposes? If we've got a car park, can we create a shelter that is made out of solar energy as well? So there's lots of potentials here. And as people start to innovate more and more and more, they're coming up with these ideas about how we can make it much more mainstream and produce the electricity that we need. And our vision really is to create a bright future. We want to help and be part of this transition, obviously in what we do, but also going above and beyond and doing as much as we can. It's why we try and spread the message like we're doing on this webinar today. And we urge everyone to become leaders in climate change. The most important thing that you can do is spread the word and then help to be part of this solution. So we invite you to create a pledge as well. Make a pledge for climate change, something that you might do to help this future and to get us into a place where we want to be. And you're more than welcome to email your pledge into our team here using the email address, and we're more than happy to hear from you if you have any questions as well. So this brings me to the end, I think in good time, of my 20-minute slot about climate change and solar energy today. You'll find a link at the bottom there. We've produced lots of educational materials that you're more than welcome to download. There's some classroom activities that you can do with your class at school. You can suggest to your teacher, and that will help you just to learn even more about solar energy and climate change. And I think I'll then open it up if there's any questions. I'm more than happy to take those. Question: how can we get solar panels onto school buildings? This can be done 100%. That would be a case of talking to your school. I would say talk to your teachers, talk to your headmaster or headmistress, and just breach the idea of getting solar panels and making your school self-sustaining. So everyone will be able to then collect energy for their school and use it, and it's a really great message to spread. But that's something that can be done. Just talk to your teachers and just get that message going. Obviously the school will have to then purchase those panels, but that's definitely something that can be done. Got any other questions for now? It can be about solar energy, it can be about climate change, just let me know. How did you get into this area? Okay, so I actually came in a slight different way to what you would expect. I actually started off studying economics. I thought I was going to go into the world of finance, but I actually started to work more in the area of sustainability and got really interested, and then thought actually this is more of what I would like to do. And then I took myself into studying more about environmental management, and that took me into solar energy and renewable energy in general. And as I said, I work in the sustainability team to try and make this already green energy even greener. What else have we got? How do you dispose of old panels? This is actually a really good question, and this is something that we work quite hard on in our company, because this is one of the points that people like to ask about solar energy. Solar panels can actually be, I think it's about 95% of the panel can be recycled. So that's exactly what we do. There's certain schemes that you can get across the world. In Europe, there's something called PV Cycle, who take care of all of this recycling process for you. So at Sonnedix, and I know a lot of other solar energy companies use these as well, we have a 0 panel to landfill policy. So we make sure everything is recycled as much as it possibly can be. Let's have a look. How can the UK improve their solar network? It's just a case of getting the investment. It takes the governments to invest in solar energy and other renewable energy to make it more feasible, to help those companies to produce more and more and more. It's easy for us to then build these solar plants to feed it into the grid and make it more renewable efficient, but it just needs investment from the government. Are solar panels expensive? This will be the last question. That's no problem at all. Solar panels used to be very expensive. The price has gone way, 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 way down. So now it's much more affordable is the short answer. So there we go. That's the last question. Thank you very much. Feel free to, as I said, email in and just let us know if you've got any more questions. And thank you very much for listening.